Let me welcome everyone to this session three of the Masterclass series on disaster risk reduction and artificial intelligence. Uh, Today, we'll be talking about AI applications for urban resilience and risk assessments. And we have presentations by Mr. Dennis and Mr. Mohamed from the Singapore Civil Defense Force and by Dr. Ansu from SEEDS Technical Services. Each will have about 20 minutes each, and then we'll keep some time for Q&A. And at the end, there will be as usual, the Slido quiz. Some of you have been asking about the certification. So those who are able to attend all four sessions will get a certificate of participation. Also, please do let others know because we do understand that many have not been able to join because of the limitations. We cannot accommodate more than 1,000. So let them know that all these recordings are available on the website and they will be there and you can watch them later. And also all the presentation materials will also be shared with you on the same website. So with that, I think I can now hand over to Mr. Dennis from the Singapore Civil Defense Force for the next 20 minutes. Over to you.
Okay, good evening, everyone. Actually, it could be good morning, good afternoon, good day, everyone. So, can you all see my slides?
Yes, very clear.
Okay, my name is Dennis, and I'm here with my colleague Hafiz from the Singapore Civil Defense Force. We are honored to share Singapore experience in using Gen AI, AI, to reduce disaster risk in our urban environment. Unlike countries facing frequent natural disaster, Singapore's main challenges are related to urbanization, fires, building safety, and emergency in a crowded space. Today, we'll walk you through our journey, the lesson we have learned, and how AI is helping us to keep our city safe. Thank you for joining us, and I look forward to an engaging session with all of you. Let me start by outlining what we will cover today. First, I'll introduce the Singapore Civil Defense Force and the unique challenges we face in our city. Next, we'll look at how disruptive technology, especially AI, are transforming our work. I'll share real examples of crisis management, incident monitoring, emergency response, and our intelligent enterprise platform. By the end, you'll see how this innovation help us respond faster and smarter to urban risks. Let's begin with a quick look at Singapore profile. Singapore is a small city-state, just 720 square kilometers. With over 6 million people living here, our landscape is filled with a high-rise building, busy business district, land checkpoints, a major airport, and a large petrochemical industry. Because our city is so densely packed, our emergency strategy must always be ready and robust to protect everyone. SCDF has a clear mission to protect and save life and property for a safe Singapore. We handle firefighting, rescue operation, hazardous material, emergency medical services, fire safety, and public protection. We also engage the community and manage shelter during national emergency. Our core values are pride in saving life and care for our people and those we serve. We are one of the few organizations worldwide to provide such a wide range of emergency services. As a small country, Singapore faces many challenges. We have an aging population, limited manpower, and high-density urban living. New technology, global conflicts, climate change, and post-pandemic reality are shaping the way we work. Disruptive technology, especially AI, are key to meeting these challenges. We must plan to operate in a future that is more volatile, uncertain, complex, and ambiguous, and technology will help us stay ahead. At SCDF, we are constantly striving to elevate our services and capability. We face evolving operational requirements and mounting constraints that challenge us daily. We are dealing with an exponential growth in data, increased public expectation, manpower constraint, and increasing complex tasks. Sounds familiar, right? By strategically deploying AI, we are augmenting our officer capability and optimizing our business processes and operation. This isn't just about keeping up, it's about staying ahead. The successful implementation of AI will enable SCDF to achieve four critical objectives. Firstly, we will be able to improve our response time and capability. Secondly, we'll be able to upscale our operation to meet the increasing demand for our services. Thirdly, AI will help us unlock hidden insight into our data, leading to more informed, data-driven decisions. And finally, by automating routine tasks, we will free up our officer for higher order activity that require human judgment and expertise. We use AI in three main areas: incident monitoring, urban search and rescue operation, and our enterprise-level intelligence platform. In the next few slides, I'll show you how AI helps us monitor emergency, find survivor in disaster, and make smarter decisions using data. These innovations are transforming how we work and making our operation more effective. In 2024 alone, last year, SCDF responded to nearly 250,000 emergency medical services calls. That's an average of 672 calls every single day, plus nearly 2,000 fire calls. Our ops center operators are the first point of contact during emergency, and they face immense pressure, gathering vital information from distressed caller, trying to enter data swiftly, spotting duplicates when multiple call comes in, and linking related incident. In respect of all these challenges, the idea of an AI sense-making platform, or AISP, was mooted. AISP is a multi-modal sense-making platform which integrates multiple AI capability to enhance emergency response operation. By combining automated speech recognition through speech-to-text conversion, video analytics, and natural language processing, the platform helps ops center operator better comprehend evolving emergency situation. This unified system augments decision-making by enhancing situation awareness through automated analysis and real-time incident visualization. The automated speech recognition system understands English, Mandarin, and Malay because Singapore is a multi-language country, including our beloved Singlish. The model is trained specifically for emergency response scenario, so it knows what to listen for. Using natural language processing, it can auto-classify incident types and extract information to create incident form. This means less manual typing, faster response, and reduced workload for our call operator, plus auto-transcription for documentation and training. Video analytics system doesn't just detect flame. It assesses severity by analyzing size and characteristic of the fire in real time. It identifies objects of interest, automatically pull relevant data from connected database, and trigger precise emergency response. What if every social media post, news report, and online conversation could become our eyes and ears during an emergency? Our natural language processing system does exactly that, scanning countless sources to extract vital contextualized information about the unfolding incident. The system continuously analyzes updated information to develop and revise more effective action to be carried out. Let me walk you through a scenario how we envisage this system work. First, we start with stage 1. In any incident, information comes in as fragmented pieces, often from different sources. For example, a caller reported a man lying on the road and bleeding at Racecourse Road. On social media, posts and images begin to surface. People describing large crowd gathering, rowdy behavior, or photo from Little India. By the way, Racecourse Road and Little India are two different locations which is nearby. Video later emerged showing a cloud blocking the ambulance. The ambulance crew reported that their ambulance was being set on fire. Individually, these pieces of information don't give you the full picture. This is where stage 2, sense making, comes in. Here, analytic tools pull all this fragmented information together, giving us a 360-degree view of the situation. Instead of scattering report, the system contextualizes the information, which allow us to filter the noise and understand what is happening on the ground. Finally, we move to stage 3, decision making. With this consolidated view, the commander are empowered with augmented decision making, with the system recommending the next course of action. In summary, this process transforms a fragmented view of an event into an actionable, decision-ready picture, helping the commander to respond more effectively and decisively during crisis. In the area of urban search and rescue operation, SCDF has been working on a proof of concept of a miniature cyborg insect to conduct search, especially in collapsed structure. This low-powered cyborg can demonstrate human detection capability through machine learning algorithm, locomotion control, and real-time positioning tracking. For this to work, the cyborg are equipped with a 5.5 gram of backpack, which contain a suite of onboard devices, including a microphone, environmental sensor, navigation sensor, and infrared camera that detect live by picking up temperature signature, and a microcontroller computer that output electrical signal to the neuromuscular leg of the cyborg to direct its movement. In the aftermath of a collapsed structure, these miniature cyborgs can crawl their way through rubble and debris, between cracks and confined spaces, searching for survivors and providing rescuers with critical information in emergency situations while ensuring safety of the resources. The current concept of operation, CONOPS, for USA mission employ specifically trained search dog from the SCDF Disaster Assistance and Rescue Team. Upon detection of survivor within collapsed structure, this search dog provide audible indicator by barking to their handler. Search specialists subsequently deploy wireless seismic sensor and video cameras probes to verify the survivor location, enabling precise victim extrication operation. Where such dogs are not deployable, the envisaged enhanced CONOPS is to deploy these Cyclops through one or multiple entry points to autonomously disperse and search for the survivor location. At the incident site, the cyborg are released to begin their critical mission. These cyborg navigate through the affected area to identify location of survivors who are trapped within the rubble by picking up temperature signature using the infrared cameras. As survivors are being found, their location are transmitted directly to the rescue team. The rescue team then maps out this precise location of the survivor to carry out the rescue operations. Earlier this year, the Cyclops are deployed in the aftermath of the Myanmar earthquake in March 2025 as part of SCDF International Humanitarian Response. While the Cyclops are not operational ready, the deployment provides crucial learning opportunity for SCDF. The team gather valuable thermal data to enhance training algorithm for detecting human in a collapsed structure, while simultaneously conducting accuracy study on cyborg positioning. These insights are now being incorporated into our ongoing system improvement. Continuing with user operation, SCDF has recently completed a proof of concept for a mobile AI unit designed to support search and rescue mission. This initiative called Menora centers on developing a wearable AI system that delivers real-time capability as rescuers move through the disaster zone. The system can detect immediate hazard and identify survivors who may not be directly visible to the rescuer. The technology uses a 360-degree mounted camera to alert officer danger outside their field of vision, significantly enhancing officer safety during high-risk operation. A chest mount radar component can penetrate through thin walls to detect survivor heartbeats, while the system simultaneously maps the surrounding terrain to determine optimum evacuation routes. This comprehensive approach enhances situational awareness and operational efficiency during critical rescue operations. Menora was further enhanced with the integration of a remote control robot to survey unknown terrain that may be deemed as hazardous for the rescuer to enter. Equipped with the advanced camera, sensor, and a simultaneous localization and mapping SAM technology, it maps unknown environment while locating itself in real time. Like our human rescuer, it carries the vital sign radar to detect survivor through subtle chest movement. Menora operates in two strategic phases. First, the robot surveys the terrain, maps the hazard around, identify survivor, and calculate the optimum pathway before returning with all this critical intelligence. Then our SCDF officer enter the risk zone equipped with the wearable AI unit that monitor the threats, locate survivor, and guide safe extraction via the predetermined routes. Next, I move on to the enterprise level intelligence platform. As the saying goes, no data, no AI. That's why SCDF is building our game-changing data lakehouse, the intelligent core, or iCore that we call it. Think of iCore as our digital brain, integrating all key data systems to unlock advanced analytic and operational insights. It powers our daily operations, enable real-time monitoring, and drives strategic plannings from one intelligent hub. iCall provides our external partner with tailored recommendation and crucial safety information, creating a connected safety ecosystem across Singapore, turning raw information into actionable insights that save lives and protect our community. iCall is a centerpiece in driving a digital to the core SCDF. By consolidating diverse internal and external data sources into a single source of truth, and applying advanced analytics, we are enabling AI to perform real-time monitoring, early issue identification, risk profiling, and optimize work processes. iCall will involve changes to the concept of operation whereby greater effort are being invested upstream for risk reduction and data is being leveraged for insights driven decision making. Building iCore require two critical components, our eyes and our brain. Our frontline sensorization network act as SCDF nerve system. IoT sensors such as CCTV and air sensor feeding into our unified monitoring network and edge-powered mobile command post. This platform don't just collect data, they synthesize it. Every sensor, every external feed, all flowing through common infrastructure to create complete situational awareness for enhanced decision making. Behind the scene, our data analytic program is the brain, integrating curated data from internal and external sources. Through powerful analytic dashboard and visualization tool, we transform raw information into crystal clear insights. In summary, AI isn't here to replace us. It is here to make us better. AI serves as our powerful augmentation tools, enhancing decision making and operational efficiency while preserving what makes us uniquely human: our judgment, empathy, and contextual understanding. As public serving officer, our success depends on strategic partnership with industry experts and Institute of Higher Learning. This collaboration drives responsible innovation, ensure ethical oversights, and align technological advancement with our public service mission. This approach directly supports SCDF core purpose, protecting and saving life and property for a safe and secure Singapore. Through people innovation and partnership, we are advancing our vision of becoming a world-leading life-saving force. Together, we are building an emergency-ready nation where technology amplifies human excellence. Thank you for all your attention. I hope you find Singapore experience with AI in disaster risk reduction both insightful and inspiring. If you have any question about our journey, our technology, or how we are building an emergency-ready nation, please feel free to type them in the chat. We'll be delighted to continue this conversation and share more about SCDF approach to the AI-powered disaster risk reduction. Thanks again. Thank you.
Thank you, Mr. Dennis. There are a couple of questions which I thought we can deal with before handing over to Anshu.
Sure.
One was regarding the automated recommendations for actions. How precise and specific are these? So that was one question.
Okay, our AI system is being trained with our standard operating procedure. So this scenario have been, it is like a huge knowledge repository where we uploaded all this information into the database. And using AI, we are able to um, so-called digest the information that is coming from various sources such as the sensor and the we are also crawling information from the social media. So by combining all this information, it is able to um, match a scenario that is simulated within the documentation that we already have to provide the uh, augmented suggestion action to be carried out. For example, if we are able, based on the information, we know that the fire involve a certain chemical or a certain material, and it will be able to share with us that water might not be the best media to put out the fire. It is able to pull out from the database to say what is the characteristic of this material that's this object that is burning, and what's the best media to put out the fire. And another scenario that is able to combine information like from the meteorological station where we get to know what is the wind speed, the wind direction. It is able to calculate and advise that how the fire is going to move, the direction of the fire. So with that, it is able to provide advice on how we are going to deploy our forces at the upstream of the wind or at the downstream of the wind. Yeah.
Thank you. And one more question there was about the Manora mobile AI unit. Somebody is asking, can it be used in case of in a fire, like in a fire-like situation? Can the person wearing that suit Can they actually enter the building because of the extreme heat and so on?
We are using it more for search and rescue. Of course, that means that it is mainly to detect survivor and casualty. So that's why the system is mounted with this low frequency radar to be able to penetrate through walls and is able and even when the visualization is being affected because of the smoke, it is able to detect survivor. So it is not suggest to use it for when you're doing the firefighting. It's in fact is for the search and rescue team. Yeah.
And a lot of questions about the cyborg insect. So because that really is something probably very path breaking. Some are asking, is it a living organism? And then how do you make sure it moves in the direction that you want it to move? And how much does this on average cost?
Uh, okay, the cost, it is basically the gigantic size of a cockroach. So this is a certain breed of cockroach that we get. Um, but for the cost of the sensor, the backpack that the cyborg is carrying, I am not so sure. I need to check with my development team.
Yeah.
Because for us, we are just in charge of giving them
Yes.
our problem statement, and the development team, basically we have another agency that's supporting us with all these proof of concept development, so the funding will be from them. But I mean I definitely can get this information from my colleague from other agency to
The
share
other
with the participant. Yeah.
Yeah, the other question was how do you control it then? I mean, it's a cockroach, right? It's walking on its own. So how do you make sure it goes in the direction that you want it to go?
So maybe I'll take this one.
Yeah.
So adding on to what Lieutenant Colonel Dennis mentioned, so it's actually a live cockroach that is being deployed, and it's the species is called Madagascar hissing cockroaches. It's quite a huge cockroach, not the common cockroaches that you see at your homes. So how do we direct then the direction of where the cockroaches are supposed to go? So the operator will output an electrical signal to the neuromuscular sites of the cyborg to direct its movement, and it's done through the backpack that it's being equipped with.
Okay, thank you. So very innovative. Thank you very much. There are many more questions in the Q&A, and I know you have already been typing some answers, but please have a look at that. And if we have time at the end, then we'll try to get back with some of those questions. So now let me hand over to Dr. Anshu from Seeds Technical Services. You have the next 20 minutes.
Thank you, Sanjay ji, and everyone at UNDRR for organizing this, and thanks everyone for joining in the session. What a privilege to be doing this right after Lieutenant Colonel Dennis and this very futuristic view of cyborgs and cockroaches being controlled. Very, very exciting. Also, this is in this series, it's a very sweet spot. You've been through the theories and how to move from theory to practicals. The last session, the next one will be more about deployment and the ethics. So today we are talking about real practical tools, some very futuristic, and I'll be taking the next 18, 19 minutes to walk you through something more a little zoomed out at the city scale. I myself come with a background of urban planning, and I'll be talking about cities and their safety. So let me take a moment and just share my screen, which is right here. And let me know, Sanjay ji, if it is visible and I move to a full screen. Okay, hoping that you can see this. This story starts 6 years ago, 2019. There was a cyclone in the Bay of Bengal, Cyclone Fani. And the use case that emerged from there was that while we give out warnings, broad warnings of where there will be impact, and we ask people to evacuate, we sometimes evacuate 1 million people in 70 hours or so. But here's a woman, we traced her story through the years from a city called Puri in eastern India. And she articulated nicely that it would be very useful if the warnings could tell her what this particular cyclone will do to her house. And you would all realize we work in this space that this is something we don't do. We give a very generic warning, but then every cyclone, every storm, every disaster is very different from another of its kind, and it even changes from hour to hour. And every house is different. So, in the same disaster event, be it an earthquake or a cyclone, you would find that a few houses get hit very badly and some others in the same neighborhood don't. So, our challenge that started from here was how do you differentiate between every single hazard event, what uniqueness it brings, and how do you differentiate between every single home, school, clinic, any other asset that you have to figure out how it would be impacted individually, maybe different from other similar units that surround it. And this was the beginning of a program that was a partnership with Microsoft and Seeds. And we have been developing this AI model for the last few years that I will walk you through. My purpose today is to excite you, is to engage with you, and for us as a sector to embrace AI, not be scared of it, and not think that it's a very high tech thing to be done by big corporations, but to realize that this is something well within our reach. We may not even call it AI, we may call it a set of programs that will help us do what you will see in the next few minutes. So, as a problem statement, what happens right now that we realize is that one, the hazard warnings do not have the kind of details we would like to have. So we may say there will be 300 millimeters of rainfall or 200,000 cubic of water coming down a river or an earthquake of 7.5 magnitude, but it doesn't tell us what it will do to individual assets. It doesn't tell us translation from a hazard to the devastation that we will see. Some buildings, some economies survive these disasters better than others. How do we start understanding that difference? And finally, a lot of people with good intentions and resources respond, but very often we find that the response is not coordinated as much as it needs to be to bring in the efficiency that we want to see. And hence, what I would do here is to show you ways that we will address these three challenges. And as a very simple graphic to start with, you know, we have seen some of this. We've all probably in our school and college years learned about how data and information are different. Data is a wide range of inputs that you get. When you organize and sort them, it starts becoming information. But let's move further from here. When these can be categorized and interlinked, they become more useful, and that is knowledge we share and we pass on. And within that very broad knowledge framework, when you start picking a few things that can make a huge difference if we work on them, these becomes insight. And actionable insights is what we are chasing through this process. If we are able to connect these insights and create a system of responding, we may not even touch 80% of what we have, but we can address the 20% that will make a huge impact. And that's the filtering, that's the sorting, and that's the automation that we try to do through such models. So specifically on what we do, we have built a model. We call it Sunny Lives. It's named after a very young colleague who was working with us when we were setting this off, and we unfortunately lost him. He passed away in a very sad incident, and we've named the model after him. So we call it Sunny Lives. As you can see in the imagery, we see rooftops. We've often seen such images before and after disasters. You can identify individual buildings that have been damaged. At the same time, you can also identify individual buildings that are at risk. They could be at risk to immediate hazards or in the long-term range. But what we also would like to, stress here is that it's not just damage. So you would have seen, and I think all of us have done initially when the phone maps came, whether Apple Maps or Google Maps, we went to our individual houses, we turned on the satellite image, and we were surprised with the level of detail we could see. Like this image, you could see a building shaft, you could see an overhead water tank, you could see the tree nearby, you could see the neighbor's car parked. And it was at that time pretty surprising. But even today, on your phone, which you may be holding or having on your desk or pocket right now, you can literally see each of about 2 billion buildings across the world. Every house, every office, every school, every health clinic. And the imagery tells you a lot about these settings. If it's very close to the seaside or a riverbank or a steep slope, very small, tightly packed houses that you can see from the rooftops literally mean that it's a slum. If it's less than 15 odd square meters, then it probably does not have a toilet inside, and it's a low income settlement in most countries where we are talking about, and we have deployed this. So, with this kind of a thinking, the tool that we are talking about today is we first build a framework. How do you detect these different assets through roof types, through the surroundings, the trees, the water bodies, the roads? How do you then, as a step two, create the model that I will show in a moment? How do you assign risk scores? How do you figure out how local can it get down to individual homes? And you can create health reports from neighborhoods to cities to districts. And these reports as outputs, whether it's a cluster level or a city level report, can then help you reach interventions, level four, which could be city specific advisories, it could be workshops and capacity building, but it could be plans to be jumping into the situation and responding, as we just heard from Singapore. So I'll very quickly walk through these few stages. In the framework stage, we will look at how in the very early days, we started doing this detection, and this is deliberately not a very clean image. This is a kind of image you would probably easily find for any area that you're trying to look at. And as I speak, please don't imagine the city that I'm talking about, but imagine your city and your neighborhood. And even in this resolution of an imagery, we could clearly identify about 12 to 13 different kind of roof types. We could identify damaged roofs, we could identify vulnerable roofs, tin roofs, plastic roofs, concrete roofs, tiled roofs, thatched roofs. And we could do a lot of proxy calculations. If it's a very temporary roof, thatch roof, it would have a earth, mud kind of a wall. And that would be great for heat in a heat wave, but it would not be great in a flood situation. And this way, when you start analyzing individual buildings, you can start figuring out what kind of a hazard would be worth considering for this case. Here, what you see is a settlement right next to a riverbank. What is the level of exposure of these different buildings? How is their vulnerability varying because of the materials, the technologies, the specific locations, and what surrounds them? And how does that help us arrive at a composite risk, which can then be used to figure out what actions we can take? So on the framework piece, we go from in this case we are using high resolution satellite imagery, but there's other data also that feeds into the same model, socioeconomic data, environmental data. You create a hazard matrix, you create a roadmap. And here I've written 30 meters. I did notice there was a question when Lieutenant Colonel Dennis was presenting around privacy, around GPDR compliance. And while in this model, there is a capability to identify buildings and risk at individual footprint level of a building, there are obviously concerns that we don't want to release such data because it can impact people, it can help identify risks that the owners may not want identified. It could put people at risk, it could skew markets. And hence, what we do here is while emergency response agencies, disaster management authorities, and city governments may have insights, but release of such data can be determined by the agency that is using it. It could be 30 meters, 50 meters, 100 meters, and you could figure out a cluster-wise response. So what we are doing is we are answering Satyavati's opening question. Can you tell me what this cyclone will do to my house? And when we run the AI model, you can see the menu, the little dashboard on the bottom right, which then generates an output view, which can help you identify buildings within a city, within a neighborhood, even within a small cluster that are at greater risk. This can help us drive frugal resources. No government anywhere or any agency has the resources to reach out instantly to everyone in the path of a incoming hazard, but you can very clearly identify a kind of a triage process that can help you figure out where interventions are needed on priority and what kind of interventions can be there. Let me also share that this slide is from Delhi. It is on the issue of heat. And to calibrate this model and constantly keep training it, we often go and deploy little data loggers. So they're not as advanced as these cyborg cockroaches, but these are little devices that record temperature, humidity, sometimes even light, literally every minute over a number of days. And we are able to figure out in which kind of a building will indoor temperature be at its worst. So when there is a heat forecast or a heat wave forecast, we know where to intervene, because in earlier times, heat was an outdoor issue. But in recent years, we are seeing a lot more stress globally, not only from the global south, but from across every country, heat stress coming from indoor settings. And this is a useful way to start understanding how the indoor temperature and humidity will behave in an upcoming heat season. And in this way, this has been used and can be, of course, further improved for areas exposed to flooding, to heat waves, to earthquakes, and flooding that is also induced by cyclones. I now move to the third part, which is what kind of outputs, what kind of reports and insights, and how you will end up using them. So there is hyperlocal, which we call very, very local, precise risk assessment within a city. When we say it will be 50 degrees, 40 degrees Celsius temperature, it's never even across the city. There is a variation of anywhere from 10, 15 degrees and even more across neighborhoods. It has often been observed, it has been researched and recorded that on an average, low income settlements and slums are about 6 degrees hotter than the rest of the city. And the city is obviously hotter than the rest of the countryside. So these are layers of information and vulnerability that come into play. Even within that slum, which is way hotter than the city, there are certain houses that are built of tin roofs or of materials that heat up very fast, and they trap heat indoors, and the indoor can be terribly hot. In this season, in this summer in the northern hemisphere, we have recorded indoor indexed heat temperatures. And by indexed, I mean taking temperature and humidity together, hovering around 50 degrees Celsius indoors in houses where during the day it's only women, infants, the elderly, people with disabilities, and even similar temperatures in schools and creches. So, emerging risks like heat, like air pollution, also have applications for this kind of hyperlocal tools that can then deliver early warnings, advisories, and highly customized city and neighborhood centric analytics and actionable insights. So this is the kind of reports you would get. You could do a multi-hazard run, you could do a single hazard run, you could geotag solutions to the resolutions that you want. And this can help us get to the kind of interventions that can be taken. In the same locations, we've been going back repeatedly for the last 5 years and trying to see how the model can perform better. We are currently getting an accuracy level of about 93, 94%, which means that out of 100 buildings that the model identifies zooming in as high risk buildings, we later on go and verify that either there was impact or there was indications of a very high level of risk in about more than 90% of these buildings. Based on that, we generate advisories, very quick advisories. Person A's house is at risk. Person B has a better three-storied house nearby, so there could be internal movements rather than evacuating entire populations. There could be very gentle advisories on how to deal with heat, which is invisible. The impacts are often initially invisible, but can be devastating later on. So working with children, working with the local volunteers and youth, literally feet on the streets, how do we go about doing that? And then there are boot camps and workshops. It's not just about governments and aid agencies delivering help. There's a lot that communities can do by themselves. So here's children getting informed on what is happening in the neighborhood, conversations happening around what can be done immediately, but what can also be done in the long run to reduce recurrent impacts. And very simple solutions. On the right, you see a woman who's very creatively used insulating sheets on her rooftop and been able to bring her temperature down with a little desert cooler that just pumps water, cooled air, and insulation to protect her from the searing sun. So that kind of interventions emerge. A lot can happen besides advisories and engagement and training. Local action can be triggered. What you see here is a little weather lab. This is a school. We are working with a series of schools that set up little weather stations. They understand the weather, the children talk to their parents and neighborhoods, and they are able to calibrate warnings in areas which are low on weather stations and high resolution data. They depend on faraway data, but they can now calibrate it for their own use. The interventions can go on. I will not be reading through this, but this is just to give you an idea that we spoke about early warnings a lot and responding. But here's a way in which this can extend into preparedness actions, into rescue and relief, the kind of work we saw from Singapore. How do you start sharpening that through insights by knowing which building clusters or individual buildings would be at highest risk? And then even recovery and reconstruction so that we genuinely are able to identify the needs of the people on the front lines and we are genuinely able to build back better. On the row headings, you will also see that this can be used by households. There can be a direct outreach, local enterprises, village councils, neighborhood councils, various levels of disaster management authorities, NGOs, and even the private sector, including real estate companies, insurance firms, port operators, airport operators, power grid operators, and such utilities. And this is my last slide. I will talk a little bit about how this gets deployed. Right now, the question is, where is this tool sitting? What kind of other tools are available, and how can you start using them in the days to come, literally starting tomorrow? So, while you can research and read a lot about such tools, there are many in the private sector zone emerging through startups, through large corporations, through the various platforms that promote AI, including OpenAI's ChatGPT, Gemini, Copilot, Claude, and others. But what we do believe is that the work that governments are doing right now is also critically important for this because eventually this is something that makes the case for a digital public good or a digital public infrastructure where information comes together. And mind you, this is the same information that we use for a lot of our developmental work and a lot of our work on emergency preparedness, response, and disaster mitigation. It's common data. It's a question of setting up the data pipelines, or we call them pipelines, but these are input channels that will bring data to one place to make it in the same format so that it can be used, it can be mined, accessed, and to be able to do that really fast, almost in real time and almost at the level of individual buildings, individual trees, individual farms, to be able to use very nice simple code, and that's where we start calling it AI. AI is basically improving our efficiency. This is stuff we can do manually, but it'll take us years, and through an AI model we are able to churn this for thousands, tens of thousands of houses and neighborhoods literally in a matter of hours. And where we are going now, literally every week there are improvements and we are tracking them, we are trying to bring them in, is agentic AI, where simple tools become, they are being called agents. And an agent could be a simple customized tool that caters to your need in your language with your data set. You can even make them closed loop systems so that your privacy issues are a little of lesser concern. They could be on secure cloud servers and you could own and control the data. But if this becomes digital public infrastructure, if this becomes an open source platform, not to be paid, to be used by everyone, then the private sector can come in and there can be a marketplace that rides on top of this. This sort of an open source community exists very vibrantly on GitHub, which is the platform where we share a lot of this material, where you will even find the model that I shared. Sunny Lives is hosted as an open source under MIT license, which means anyone can use it, anyone can change it, adapt it, deploy it, use it for your communities, even take it to market and create marketplace products that can be sold over it. So with that, I invite you to GitHub. I invite you to play with such stuff. If you're going to ask me questions, please ask around how literally tomorrow and next week you can start using these tools. Uh, If you don't have the bandwidth or the interest to literally get into code, which has also become much easier in recent months, you could just find a local college with a computer science department or a couple of young interns to join you, and we could be doing amazing stuff. Great magic will emerge from here. Let's embrace this. Let's see how in the next few weeks, months, certainly by next year, there will be a lot of efficiency that we will see through similar tools. I'll pause here. Sanjay ji, over to you. Back.
Thank you, Anshu. And there are a few questions. There are many questions actually, but we have only 5 minutes for Q&A now for your. So one is about the Sunny Lives model. How are you coordinating with the national authorities regarding the outputs and the planning?
Yeah. So let me respond this not just with Sunny Lives, but also with the assessment and response that I spoke about in the end. Today, I focused more on risk assessment because that was the title of this masterclass. But this is something we have piloted in India. We are coordinating with the National Disaster Management Authority, and we got very good advice from the authority saying that it should rise from the ground up. So there's about half a dozen states where we are deploying this. We are working with state disaster management authorities. But what excites me the most is while we work with a state authority or a city municipality, we equally work with local schools, local colleges, local community volunteers, and NGOs. And that is the ecosystem we see coming up. So we have certain proofs of concept. We do believe there's a lot more that can be done, and of course improvements will is a non-stop thing. As I said, the model has a high level of accuracy. The accuracy level we believe will not touch 100% for a very long time to come. Even Google Maps or Apple Maps are not at 100% accuracy. You still get lost once or twice in a year, and hence there will be safety nets. There must be safety nets everywhere that we do this well. But it's and so far we are having a fairly good reception from the authorities wherever we have taken this. And I hope in the coming weeks and months we will report back a lot more on this. Sanjay ji?
Another question was about the identification of the roof. So that is done by the AI, the
It
the,
is
the type of roof.
absolutely, it is absolutely done by the AI, and it is very fascinating to see how this happens. It happens almost in real time. You can throw an image at AI, and of course, I must say it did not happen overnight. There were for the first 2 years, we were just feeding this data. We were taking thousands of rooftops, we were identifying them manually and feeding them into our database. That is what we call labeled data in the AI world, where we have pre-labeled, and the software learns to identify what features are leading to an outcome when it becomes thatch, when it becomes tin. So color feeds into it, the grades and the lines that are there feed into it, reflection of light feeds into it, the shape feeds into it. But now, as of now, it is completely automatically done by the AI model. Sanjay ji?
Thank you. And one more question was that has any of these tools been shared with other countries or applied in other countries?
So we started as a philanthropy supported program 5 years ago. As I said, this is part of Microsoft AI for Good Lab and Microsoft India and Seeds program. We have been sharing this through these channels. I have been taking it and presenting this in Southeast Asia. A couple of years ago, we presented in the US in a large AI event. It is not yet deployed as a formal process, but it has been tried and tested in various disasters in the Middle East, in South America. We are sharing it as a proof of concept. I would even urge this audience to literally take it and try it. This is not a off-the-shelf product that can be picked and deployed tomorrow. And we do understand every country, every community has its own nuances, and it'll need to be adapted. So it's in that process. I don't expect to see the entire world using this or any tool like this literally overnight in the next few months. But we do believe that a range of tools of this kind, a lot of them out of the open source community, a lot of them as digital public good, will be seen deployed in a number of places. Sanjay ji?
So another question is that the roof recognition is open access, correct? Because they are asking that in one country they are planning to develop a algorithm but they
Yeah.
lack the roof recognition part.
You do not need to reinvent the wheel, sir. Anyone wanting to do this, so there are three parts to this very quickly, Sanjay. The first part that the model runs is we call it building segmentation. It identifies buildings and what we call footprints, the shape of the building, right? The second part of the model identifies the roof type. And the third part of the model puts together the building, the roof, the surroundings, the topography, slope of the land, vegetation, water bodies, and it assigns risk assessment scores to that. All of this is open source. All of this has been done. Of course, it can be improved. So please, instead of starting from scratch, take what's available, play with it. If you like it, improve upon it, use it in the way you like. Sanjay ji.
That I mean, for now, that's it. There's just one request that can you share the link to the GitHub community in the chat?
I will do that in a moment.
Okay.
Thank you.
And to end with the cockroach again, there is a question about have you been able to compare the efficacy of the cockroach as or the cyborg insect as compared to a real search and rescue? You know, what is the level of accuracy? Or of course the cyborg insect is able to go where humans cannot go, but other than that, is the sensors as accurate?
Okay, for this one, because currently we are still doing the proof of concept. We the latest deployment that we have tried out is during the Myanmar earthquake in March 2025, early this year. So from that trial, we are um, seeing that there are more work to be done to fine-tune how we can actually accurately control the movement of the cyborg using the electrical signal. Other than that, the detector, the sensor that the cyborg is carrying is actually working fine. That means that it is able to pick up, the microphone is able to pick up the sound. The infrared sensor is able to detect temperature gradients. So for this, for me, it is still too early to make this assessment as we are still at a quite an infant state of doing this trial. Yeah.
Thank you so much. Thank you, all of you. So now let me hand over to Alf to conduct the quiz. Alf.
Thank you very much. I will then share my screen. I hope that you are able to see. Maybe not yet. I hope that you are now able to see my screen.
Yes. Yes, we can see now.
So
I think
those of you who have
you can go ahead.
participated in this quiz before, you will know how it works. You go to slido.com, enter the code on your screen, and you enter a nickname. And I see that a lot of people already are entering, which is great to see. We have assembled 6 questions. All of them are of the type true, false, like during the 2 first sessions in this series. And they're based on today's presentations from Singapore and Seeds. So we'll give a few more seconds for people to log on. And those of you who are new to this, you should know that in order to maximize your score in this quiz, you need to answer correctly, but also quickly. The faster you answer, the more points you will get.
I think you can start now.
Okay, then we will start the quiz, and it's still possible to join along the way for those who missed the beginning. So we'll start. So first question, Singapore's main focus is on managing and mitigating urban risks rather than addressing natural hazards like earthquakes or tsunamis. True or false? Yeah, most of you thought that was true, and that was indeed true. Their focus is on managing and mitigating urban risks. Second question, the AI sense-making platform streamline operations by automating monitoring and interpretation of speech, visual, and text data, providing situational awareness and decision support during emergencies. True or false? All of you thought that was true, and it was true. Third question, iCore is a scalable platform that brings together data from multiple sources to provide advanced analytics and operational insights for SCDF. True or false? Yeah, that one was true as well, as most of you got that correctly. Then we move into a few questions from the SEEDS presentation. Number 4. Completely different datasets are needed for risk assessment and post-disaster response with no common parameters. True or false? Yeah, 2/3 of you thought that was false, and false was the right choice. Fifth question. Agents are programs created through software for carrying out specific tasks using AI. They can be useful for customized actions in disaster risk reduction work. True or false? Yeah, almost everybody thought that was true, and the correct answer was true. Then is the final question, number 6. AI is still new and a very expensive technology for customized DRR use, available only through private tech companies. True or false? Yeah, most of you thought that was false, and false was correct, as we heard a lot of open source AI available as well, and open source tools that we just heard from SEEDS. So correct answer was false. And today's winner of the quiz was Ed Wright. Congratulations to you, and congratulations to everybody who got everything right and who participated in this informal quiz. So back to you, Sanjaya.
Okay, so with this, let me thank the Singapore Civil Defense Force and SEEDS for making for sharing all this knowledge and experiences and cases with us and inspiring us. And there are lots of questions, many of which have been answered. And I also like to thank all the participants, and we'll see you all again on the 21st of October at the same time. So with that, we end this session today. Thank you all.